Hi, I'm Jeff Wimmett, and I'm an applications engineer here at Altera. You may have seen our previous video outlining 5 easy steps for building an embedded processor inside an FPGA. That featured the BeMicro FPGA evaluation board. Well, did you know that soft-core FPGA processors provide some unique benefits that you simply can't achieve with commercial off-the-shelf processors? In this video, we'll show you a quick demo of the software development tools for embedded processors, and then you'll learn 5 reasons why you should put your processor on an FPGA. We'll cover design flexibility, guarding against obsolescence, multi-core support, hardware acceleration, and most importantly, you'll see from our demo that we have all the software tools that you're already familiar with. As we go through these points today, you'll get a good look at what you can do with our Nios 2 embedded processor and the BeMicro SDK, which is one of the newest offerings from our partner Arrow. Let's get started. Our demo setup here is pretty straightforward. Here's the BeMicro SDK evaluation board. You can see it has a very small form factor. Now we'll plug that into our PC, like so. Our primary software development tool today is the open source, Eclipse-based integrated development environment with Nios 2 plugins, which we call the Nios 2 Embedded Design Suite, or just EDS. Now, if you're familiar with Eclipse-based tools, you'll be right at home here. Now, I know that there are some of you out there who prefer to use command line-based tools along with some scripts. Don't worry, we've got you covered as well. To start our demo, I'll go ahead and launch the integrated development environment, which is called the Nios 2 Software Tools for Eclipse. Select Start, Altera, Nios 2 Software Build Tools for Eclipse. I'm going to just select the location for our project. We'll just accept the default here. Now, there are several templates that come with the Nios 2 EDS. These make for easy starting points for new designs. We'll use one of the available templates for our demo today. So I'll go here, select from the File, New, Nios 2 Application, and BSP from Template. Click on that. Now, BSP stands for Board Support Package. And what that implies is that we have a predefined hardware system on which to run our software code. And we do. Today it's the BeMicro SDK board. In order to set up the software to use that board appropriately, all we have to do is select any one of the SOPC info files that are created when the hardware design is done. So I'll browse to one which ships with the BeMicro SDK and select it. I do that right here. And you can see the BeMicro SDK example.sopc info file here. And down here you can see the list of available templates. Here's Hello World, which you're probably familiar with. And you can see the others are here. For our demo today, we'll use Count Binary. So I'll select it there. And then I just need to give our project a name. So I'll type here BeMicro SDK. And then push Next. And you can see the option here to create a custom BSP based on the SOPC info file that we've selected. This file describes the entire processor system, including all the peripherals, the memory map, and so on. We definitely want to do this, so we'll leave this option selected and then push the Finish button. Now the software needs a few seconds to go ahead and create a project for us. But when it finishes, we'll be able to look at the files from the template in the Project Explorer window. And now that the project's been created, you can see in the Project Explorer window here and see the actual C file that represents our binary counter. Here it is here, and if we double click on it, then you can see the code development perspective here. And here's the code for our binary counter. Now, this tool is helpful. It will perform line completions for you, and it has other built-in niceties, like, for instance, if I were to highlight one of these variables here, you can see the other instances of it get highlighted as well. Okay, now let's take a look at the debug environment. Now, it's no fun to debug code that doesn't have any bugs, so let's create one. Let's just delete this increment command from this variable called count. That should create an interesting problem for us to go and investigate. Okay, so let's pretend that we've just completed writing this code, as opposed to having just completed sabotaging it. After the code is written, it needs to be compiled and then downloaded to the processor that's running on our BeMicro SDK board. So we save this, and then if we right-click here, you'll see you have two options here. We can select Run as Nios 2 hardware, or just below that here, Debug as Nios 2 hardware. Now both these commands will perform the compilation and the download, but the Debug as option will open the debug environment. And I've got a sneaking suspicion that there's something wrong with our code, so let's go with that one. The software now takes a second to compile our code and then download it to the BeMicro SDK board. And by the way, the USB blaster cable, which is our download and debug probe, is actually built into the BeMicro SDK board. So all we have to do is select that debug and hardware option, and it'll compile the code, download it to our processor, and we'll be ready to debug. Okay, so this is the debug perspective. And you can see up here we have our variables list. We can also set breakpoints, have a look at various registers or what's in memory, and so on. We also have over here our code. And you can see that we're paused right now at this point. So if I go select resume command from here, then our code will resume executing, and you can see down here that something is definitely wrong because we are not counting from 00 to FF. We've got 00, 0, 0, 0, 0. So let's pause our code. Selecting pause. We'll go to our variables window, and if we right-click here, we can select to add global variables. We'll do that, and let's take a look at, how about this one called count? Might be something wrong with that guy. Now you can see counts here. You can see the value. So we'll set a breakpoint over here in our code. We can do that just by double-clicking here. And then we'll go ahead and run through it once. And we saw 0, 0 there. Counts 0, 0. Do that again. It looks like count is staying at 0, 0. So if we go look at our count binary.c file, you can see, yep, look at that. There's no increment on our count variable. So we'll go ahead and add an increment to that. We'll save our code. And then once again, we want to switch back to our coding perspective so that we can recompile and download our code. And again, we do that by going to Debug as Nios 2 hardware. And we'll wait for the tool to compile our code, download it to our BeMicro SDK, and then see if we're counting away or not. So we'll select Run, and you can see 00, 01, 02, we're happily counting away here. Now, remember, Nios 2 is a soft-core embedded processor that will work on any of the Altera FPGAs or hard copy ASICs. And because you can reuse it for any of the next generation devices, it'll never become obsolete. Since it's a soft-core system, you can also include any combination or number of peripherals, processors, and interfaces. You can also increase system performance by using multiple Nios 2 processors, or custom instructions, or even hardware accelerators. So you can see that using Nios 2 maximizes your design flexibility and scalability. And remember, you're not limited to only using Nios 2. You can also use one of the other soft-core processors that's targeted for Altera devices, like the ARM Cortex-M1 or the Freescale V1 Coldfire. Take advantage of the variety of different tools and resources that are available to you, including leading operating systems such as MicroCOS2, Linux, and ECOS, powerful debug tools from Lauterbach, reference designs and development kits, and our online communities, the Altera Forum and Wiki sites. Remember those 5 things we started out with? Design flexibility, guarding against obsolescence, multi-core support, hardware acceleration, and those easy-to-use software tools? Now that you've seen the benefits, we hope you're ready to put your processor on an FPGA. You can get started on your embedded design with any of our development environments. You can also download the Nios 2 Embedded Design Suite for free. Go to altera.com/download for more information. But the easiest and fastest way to get started is with the BeMicro SDK from Arrow Electronics. Get the details on that at altera.com/BeMicro SDK. I'm Jeff Wimmett. You keep on designing, we'll keep on making it easier. Thanks for watching.